Intercepts. We're going to be talking about intercepts now. To give you a visual of what we're talking about, let's draw an XY plane. Now if I draw a line as such, where the line crosses the x-axis is called the x-intercept. Where it crosses the y-axis or intercepts the y-axis is called the y-intercept. And if we were to label a few points on this x-axis, and we're counting by ones, if you were asked to signify what this point is, you would say that point is 1, 0. This point would be 2, 0. This point will be -3, 0. And if you do all of those points, which you can't, but if you were, you see a pattern develop. Every point on the x-axis has a y value of 0. So an arbitrary point on the x-axis would be x, 0. Now, for the y-axis, if we label that point and that point, that would be 0, 3. This point would be 0, 1. This point would be 0, -3. So any arbitrary point on the y-axis would be 0, y. The point of this is to give you an idea of how to find x-intercepts and y-intercepts algebraically. Since the x-intercept is where the line crosses the x-axis, that must be a point on the x-axis. And every point on the x-axis is of the form x, 0. Keep that in mind. Y is always 0. So in other words, to find the x-intercept, y must always be 0. The same notion is true for the y-intercept. Since every point on the y-axis is of the form 0, y, and the y-intercept is a point on the y-axis, it must be of the form 0, y. To find it algebraically, that must mean that x must be equal to 0. And that's the procedure we're going to use to find the x and y intercepts. To find x-intercepts, set y equal to 0, solve for x. To find y-intercepts, set x equals 0 and solve for y. Now let's do this example, and we'll do another one just to make sure that we're all comfortable with what we're doing. So for the x-intercepts, since we want to know what the x value is, we're going to let y equal 0. So everywhere we have a y in our equation, let me write the equation down again, we're going to substitute it with 0. And then from there we're going to solve it as if it were any linear equation. We're going to multiply, and then we're going to add, which those aren't like terms because 2x plus 0 is 2x. And then we're going to divide by 2, and we're going to end up with x equals -6. Now that is not the x-intercept. The x-intercept is a point. That point was when x was -6, we let y be 0. So your x-intercept is -6, 0. Now for the y-intercept, we want to know what y is, so we're going to let x equal 0. So let's take our original equation. Everywhere we have an x, we're going to replace it with a 0. Solve for y. Now hopefully you'll come to a point where you'll see what's going on. You can bypass some steps. 2 times 0 is 0. 0 plus anything is that anything, so it just leaves 3y. Essentially what you're doing is replacing the 0 for the x and for the y to get rid of all those x terms and get rid of all those y terms. So we have an equation solving for only one variable. In this case, it's y, which equals -4. So that point is 0, -4 because the y value was -4 when we let x be 0. Now we're going to graph. So, and all we're going to do is take those 2 points that we found, -6, 0 and 0, -4, and we're going to use those 2 points to graph. All we need is 2 points. -6, 0 would be 1, 2, 3, 4, 5, 6 to the left, and stop at 0. -6, 0. 0, -4, since x is 0, y is -4, we're going to go down 4 places on the y-axis at negative 4. Put a point there because that's 0. Doesn't go to the right. Down negative 4 to the y value. And we're going to play connect the dots, but always extend the line. And there you go. We have the graph of 2x plus 3y equals negative 12. And it's intersecting the x-axis at negative 6, 0. And at the y-axis at 0, negative 4. Now let's do another example. And let's show you a little shortcut way to do some of these. You may or may not want to do this, but that's fine. Let's find the X and Y intercepts. Of this problem. We're going to do this one really quickly. Let's just use something simple like 4x plus 5y equals 40. Now let me show you a little quick way to do this for equations like this. To find the x-intercept, let's just cover up the y value. And we're solving 4x equals 40. Now that tells me for 4x to be equal to 40, x must equal 10. And I'm done. 10, 0. For the y-intercept, let's cover up the x value. When I solve that for y, that tells me y equals 8. Y is 8. It's as simple as that.